Hello, welcome back. This is for Math 261, Applied Calculus 1. I hope you had a great spring break. But this is gonna be how we'll be learning for the plan for right now is until April 4th, but we'll see. But if you have any questions, I do want you to know that I am available for Zoom conference. We can meet online. We're just not allowed to meet face to face anymore. But email me if you have any questions, concerns. We will talk about the second exam probably next week. But today, I'm going to have two videos for you to go over section 2.6. So let's take some notes. So let's write down on Math 261, Applied Calculus 1. All right, let me zoom in so that you can focus. This is for section 2.6. Section 2.6, and it's called the derivative of a to the x and log base a of x. So we're doing two different things. And I'm going to do this one first. It's just a little bit shorter. I have about 9 different examples I want to go over with you. And after I show you all those 9 examples, I will give you 4 problems for you to try. Okay? So the 4 problems, I want you to write them down on a piece of paper, work them out, scan it, and submit it on Canvas, either as a PDF or a picture file, so that I can check your work. But let's try that. So the first one isn't really the example. We want to come up with in our textbook it's called Theorem 13. We want to find what the derivative of log base a of x is. So do write this down for me. Use the change of base formula to find log base, not log base. We're going to find the derivative of that guy. The derivative with respect to x of natural log base a of x. So we'll do this first, and then if you like to use that, formula or theorem, you can. But I tend to keep on using this change of base formula for every problem. I like it. Well, but do remember one thing that we talked about before spring break. Remember that the derivative of natural log of x is equal to 1 over x. Right? I hope you still remember this one. This log expression is base e. Right? We're trying to do the derivative for log expression with an e base. So a is not e, but we're gonna use what we know already to solve it. But remember the change of base formula. I will rewrite this expression using the change of base formula, okay? I can use common log or natural log, but I'm just gonna write this as a ratio of natural log. So first, start by writing that log base a of x is equal to natural log of x over natural log of a. Now that is the change of base formula. And we really didn't use this too often unless we were trying to evaluate a log expression on a calculator that didn't have the log base function. But we're going to have to use this one. But now I'm going to take the derivative of both sides, okay? So the derivative with respect to x of log base a of x is equal to the derivative of the right side, okay? Alrighty, let me move this up. I'm going to simplify this right side. The right side, I can write this as a multiplication of 1 over natural log of a times natural log of x. You see what I did? I just brought this exponent, I'm sorry, not exponent, this numerator down like this. And I just wrote this over ln a as 1 over natural log of a. But let's take the derivative of this, and what you notice is if you're taking the derivative with respect to x, this, what I'm highlighting in yellow, is just a constant. There's no x here, right? There's no x anywhere here. So what I can do is I can just pull this to the front. There's no x, so we're just going to bring it to the front. 1 over natural log of a. And then I'm going to find the derivative of natural log of x. Okay, so the yellow piece got out. It's right here. So what I have left was the derivative of just the natural log of x. Now look up there for me. We already know what the derivative of natural log of x is. It's 1 over x. So let me rewrite, well actually we're almost done. So this will turn into 1 over ln a times, now what's this? What's this? That is simply 1 over x, right? So that's okay, but I can put these two fractions together. I can multiply them and write it as 1 over, let me write this x first, x times natural log of a. And that's it. That is the derivative of log base a of x. So let's write this down. And in the book, it's called Theorem 13. It's called Theorem 13, but I don't really use, well, I love using this change of base formula because it's not that complicated. And I think I will keep on doing that. All right, anyways, what's that theorem? It is that the derivative of log base a of x is equal to 1 over the argument times natural log of that base a. So this is it. If you are good with patterns and memorizing the formulas, you can try to just use this theorem. For example, what if I ask you, example, find the derivative of log base, I'm making up a random one, guys, 5 of x. What's that going to be? Using this rule right here, or this theorem 13 right there, I can say that is equal to 1 over x times natural log of the base, natural log of, what's the number? 5. So you can do it this way. Maybe another one. Derivative of, okay, how about I make it like this? Now, what's the base here, guys? The base is not written for a common log. So what is the base hidden? The base is 10. So, well, if you do that using this rule, it will be 1 over x times natural log of the base, natural log of 10. So if you like it, if you can just go straight from the derivative to this, that's fine, that's fine. But I tend to keep on going back to the change base formula because I like it. So that's the theorem 13 that we will be using for the next about 9 different examples. Of course, I'm going to throw in some chain rules for review. But after those 9 examples, I'll ask you to try 4 problems on your own, okay? So you ready? Well, and thank you for taking the notes on your paper. I didn't really have a way for me to make copies and deliver those to you. So example 1. Let's do an example 1. I don't know if you can hear my neighbor's dog barking outside, but they're so loud. Okay, anyways, so let's go ahead and make examples. Whole bunch of examples. I gotta keep on pressing this focus button. Focus. Number 1, I say y equals, the rule is to differentiate all of them. So here's the first one. Y equals log base 8 of x. Now this one you can use that theorem 13 straight, but I can make it longer. I can do it the longer way. By the way, what should the answer be? The y prime should be, I'll just write it on the side. Y prime should be 1 over x times natural log of what number? 8, right? So that is the answer. Well, why not? I don't have to stop this lecture in, hour and 15 minutes like every day. So I'm just going to keep on going. All right, so what's that going to be? I can rewrite this as natural log of x times or over natural log of 8. What am I using here? What property am I using here? I'm using the change of base formula, right? And now I can rewrite this as y equals 1 over natural log of 8 times ln x. And I'll take the derivative of this. So y prime is equal to, well, you see, this is just a constant. That's just a constant, so I'll write this down as 1 over natural log of 8. Nothing changes about that. But you know the derivative of natural log of x is what? 1 over x. So if I put these two together, I will get 1 over x times natural log of 8. And that is that answer right there. So up to you. I like just doing it the longer way. Let's try two more simple ones. Number 2. You have y equals log base 2 of x. Okay, so using that theorem 13, we do know the answer is y prime equals 1 over x times what? Natural log of 2. And when you're doing your My Math Lab homework, if you just want to do that, that's fine. But I just want to do that. Change base formula. So y equals what? ln x over ln 2, right? I can pull out this 1 over ln 2, which is a constant, and write that as, let me hit the focus button one more time. I can separate this fraction into two pieces, right? And then here I go, taking the derivative. There's no x in this first fraction. 1 over natural log of 2 is just a number. So that just comes down as natural log of 2. But you do know that natural log of x, I like how we get to review this because it's been spring break and probably you forgot some of these rules that we did before spring break. So that's just 1 over x. The derivative of natural log is 1 over x. So if I put them together, I get 1 over x times natural log of 2. So it's that one. Okay. All right, how about you try this one? Number 3. I'll give you y equals log x. You're like, uh-oh, what's the base? See, the common logs, they don't have the base written, but you do know if it's just log x, the base is really 10, right? So the base is 10. So, you know what? I will use a shortcut this time. Y prime is equal to 1 over x times natural log of 10. And that is the derivative of our y. Now, of course, you can try to do that using the change base formula, but I think we've seen enough of that. Let me go down to another example. In fact, let me do it right over here because it's just something added to number 3. How about if you have number 4, y equals negative 7 times log x. What's that going to be? Well, we just found the derivative of this, didn't we? We know what that is. That's going to be 1 over x natural log of 10. And, well, that's the constant, so we'll just bring it down. And I can put it in front of this fraction, or on top of this fraction. So I'll just put minus, I'll just change it to negative 7 there. So the derivative is equal to negative 7 over x ln 10. So if it's just constant in front, that's what we can do. Alrighty, I got a couple more to show you. Now let's actually make it a little more complicated, okay? Something like, some chain rule. Okay, so number 5 and 6, let me make up examples that will let us use some chain rule. Number 5, still differentiating. Let's make it y or f of x equals log base 3. But this time the argument is not just x, but let me make it x squared plus 1. Okay. All right. I'll do the change base formula for this, but you can still use that theorem 13. You just got to remember to use the chain rule. But here we go. Let me rewrite f of x as natural log of x squared plus 1 over natural log of what number? 3. So I use the change of base formula to rewrite my f of x. And I'm going to pull out that denominator and write it as 1 over ln 3 times natural log of x squared plus 1. Okay, now notice I didn't take the derivative or anything just yet. I was just keep on rewriting my f of x, and now I'm going to take the derivative of this. Notice this is just a constant, right? That's just a constant, so just write it down. 1 over ln 3 times. Now, let's take the derivative of this one. The derivative of natural log of x squared plus 1. You do need a fraction that has 1 over x squared plus 1. But remember to take the derivative of the inside part. We gotta multiply this by ddx of x squared plus 1. And I know a lot of you just do this part in your head and write down 2x, but I wanted to show where that 2x is coming from, so I wrote it one more step, okay? So let me write this one more step one more time. 1 over ln 3 times 1 over x squared plus 1 times, and now if you do that, if you take care of that, you will get just 2x, right? Just 2x. This part right here, let's see if I have another color. Ooh, Sharpie. This part right here is the derivative of the inside part, okay? So that's the chain rule right here. And then I'm just going to have to put these all together, okay? So f of x, or f prime of x, is equal to, now what goes on the numerator? Just the 2x. 2x divided by natural log of 3. I put the 3 in a parenthesis, and then that's getting multiplied by x squared plus 1. Okay, and that is the answer. Oh, that one was a little bit tricky, wasn't it? Let's do maybe 2 more, just like this. Just 2 more, just like this. But that's number 5. Then I'll give you a problem like this for you to try on your classwork. Write down number 6 for me. 6, let's try f of x equals log base 8 x cubed plus, let's make it interesting, 2x. Ooh. Okay, let's try this one. Change your base. So f of x equals, what's on the numerator, guys? The numerator, the top of the fraction is ln x cubed plus 2x. And what's in the bottom of the fraction? Natural log of 8. All right. Pull out the fraction or the denominator. Pull out 1 over ln 8 and say that's getting multiplied by our numerator. And now we are ready to take the derivative. Ready? So f prime of x is equal to, hello, constant. This constant just comes straight down. It's constant because there's no x here, right? It's 1 over ln 8. So just copy that down. But now, let's take the derivative of this one. Do write down 1 over x cubed plus 2x. But guess what we're going to multiply this by? We have to multiply this by the derivative of x cubed plus 2x. Okay, we're going to multiply that by the derivative of x cubed plus 2x. That's going to give us 3x squared plus 2. Okay, now last thing to do is just putting all these together. What's my numerator? This red expression. I'll have 3x squared plus 2 on top of my fraction. And in the bottom of my fraction, let me put natural log of 8 times x cubed plus 2x. And that is it. That is our prime. How was that one? Are you doing any better with number 6? I'm sure you're doing really, really good. One more chain rule, and I will end with some product rule examples, okay? Number 7. Write this down. Well, I'm tired of f of x. Let's go with g of x. G of x equals a log base. I'm not gonna tell you what log base. X to the 12th power minus 8x squared. How random. Okay, let's take care of that. So use the change base formula. What will you get? You get that g of x is equal to a fraction. The numerator is natural log of x to the 12th minus 8x squared. But what will you put in the bottom of the fraction, guys? And you're right, we're gonna put natural log of 10. And where did we get this random 10 from? It's a common log. The hidden base is 10 right here. Okay, now I'm still not taking the derivative yet. I'm just rewriting it in a form where I have clearly a constant, the denominator, times 1 over denominator times natural log of this expression. And differentiating this expression is what we practiced like crazy before spring break. Now let's go ahead and finally take the derivative of g of x. Okay, so 1 over natural log of 10 stays exactly the same. Now what's the second one that we need? We need 1 over x squared, x to the 12th power minus 8x squared. Now look, because this expression right here now needs to be differentiated, we need to take the derivative of this mess. What's that going to be? You'll have 12x to the 11th power minus what number? I'm going to need 16x to the first power. That's it. Now the last part is the easiest, isn't it? G of x equals, just put them all together. Let's put this red expression on top of the fraction. 12x to the 11th minus 16x all over natural log of 10 times x to the 12th minus 8x squared. And that's it. Okay. I think I'm showing more than enough, but you know that's good. That's good. Now number 8 and 9. I just have 2 more examples for you. They're very similar, but number 8 and 9 are both using the product rule, which is a good review of what we've been doing. Write down number 8 for me. I use f and g. Let's call it h of x. Write down h of x equals x to the 3rd power times log base 5 of x. Ooh, okay. Focus this so that you can write it down. Obviously, we see a product of 2 things, right? Now take a look. We have x to the 3rd power times log base 5 of x. So we will use the product rule. We're going to treat this as, that's my f, and that's my g. Okay? So review of what is a product rule. Product rule. Let's write this down in this little corner, okay? The derivative of f times g is equal to gf prime, fg prime plus gf prime. I think that was the order we used before spring break. But basically, I need my f, g, f prime, and g prime, and we kind of started listing them in the corner, right? So let me write all of these down. F equals x cubed. Well, x prime equals 3x squared then, right? What about g? G is log base 5 of x. And then g prime is equal to, now, did we do this one? No, not yet. But you know, I'm using theorem 13 so that I can just do this one real quick. 1 over what? X times natural log of 5. Now, where did this come from? Take a look at example 1, 2, and 3. You can do this the longer way, but I just wanted to save some room. The derivative of log base 5 of x is 1 over x times natural log of 5. Now, using these 4 pieces, let's find the derivative of h. So what's h prime? H prime is equal to f times g prime, f times g prime. F is x cubed G prime is, where are you? Oh, down here. Oh, I'll just make it as over x times natural log of 5 plus sign. G times f prime. G is log base 5 of x times, what's f prime? F prime is 3x squared. Okay, that is it. But let me simplify this one more step. Do you notice there is x cubed? And there is x right here. So we can simplify that. We'll just write this as a fraction that has x squared on top. No more x in the bottom, just natural log of 5. Plus, there's nothing I want to do about this. Maybe I'll just switch the order. Doesn't matter. This is fine as is, but maybe I'll just write it as 3x squared times log base 5 of x. But really, we'll try to type in how we're doing on My Math Lab. If they say they don't like the order that we're doing this, then we can come back and talk about how to put this as a single fraction. But I think this should be fine. This should be fine when you do your homework. Now that one was a little bit, well, it had more to it. So let's do one more, and that will be it for the examples in this video. Let's do example number 9. A piece of paper. And oh no, this is gonna be my last one. Number 9. Write down. Let's do k of x. K of x equals x to the 6th power. X to the 6th power times log x. Woohoo! Okay, so obviously, do we see a product? We see that this is x to the 6th power, which is our f, times log base x. Let's call that our g. So we have a product. We have f times g, and the product rule, fg prime is equal to fg prime plus gf prime. So this is the product rule that we're going to be using. Let's write down all our little pieces then, okay? So f equals f prime equals g prime equals. I started writing my little pieces after the first exam because I think it's easy to have them all listed and just put them together when we do the product rule. F is x to the 6th power. That means f prime is what? 6x to the 5th power. Now g is log x. And now we did this one. We took the derivative of log base x somewhere, and that was number 3. Example number 3. And that was simply 1 over x times natural log of 10. Remembering things that we did before makes our work a little bit easier. So let's put everything together. K prime of x. Okay, I need f times g prime. F x to the 6th times g prime. G prime is the fraction. Oh, so I'll just write it as over x times ln 10 plus gf prime. G is log base x, and I'm going to multiply this by f prime, which is 6x to the 5th power. So if I simplify this little bit, x to the 6th and over x, that will turn into x to the 5th on top of the fraction. Natural log of 10 still in the bottom, and that's fine, but I'll just write 6x to the 5th first. And that is it. That is our k prime of x. Now that's really enough. I think you've seen enough of the derivative of log base a of x. So let me make up 4 problems for you to try on a separate sheet of paper. Take a picture, scan it. I use something called Cam Scanner on my cell phone. It scans it into a PDF document. I can't make you download an app, but if you don't have a scanner, there are apps out there that you can download so that you can scan it in a nice quality document for you to submit on Canvas. Let me see. Let me give you 4 problems then. I gotta have a set of problems somewhere. guys. Oh, I got this. All right. So, I'll call it 2.6 Part 1 classwork. 2.6 Part 1 classwork, because there is going to be Part 2 later. So, I want you to find the derivative, or I'll just say differentiate. You need to show me a good amount of work, okay? Like number 1, I'll make it simple. Number 1, do y equals 5 times log base 11 of x. Now this one I think is similar to number 4, example 4 that we did. That's a simple one. Now number 2, do this one. Let h of x equals log base 3 of negative 4x squared plus 5x. That's the one where you have to use the chain rule. And you know what? Let me just do 3 problems. Okay, let me just do 3 problems. Now, the last one, I want to make it similar to like number 9 that we just did. Okay, so try this one. P of x is equal to x to the a random number. Today is the 17th. 17th power times log base is March 3 of x. Okay, so these are 3 problems I want you to try for the first part of 2.6 lesson. I will come back and post and record and post another video. In that one, I will talk about the derivative of a to the x power. But that's for the first part. Oopsies. I'll stop the video now. Who's calling? And then I will come back and see you later. Okay? Thank you for watching. Now let's see how do I stop this.